Hello students, the next topic we are going to discuss in this video is that law of conservation of total linear momentum. So conservation is that to preserve, that is there will not be any change in the linear momentum. The change value will be 0. You're going to derive that. So law of conservation of momentum of law of conservation of total linear momentum. So first we have to get the total linear momentum. So to get total linear momentum, we can derive this from Newton's third law and Newton's second law. That is conservation. Okay, conservation of linear momentum can be obtained from Newton's third law and second law. So Newton's third law, we know that for any action there will be equivalent and opposite reaction. That is, if you have force in one direction, there will be equivalent force in the opposite direction also. So which is F21 equal to minus of F12. This is Newton's third law. And Newton's second law, we know that F is equal to ma, and we have derived that F is equal to ma from the change in momentum. So which is given by F12. F12 is nothing but force acting on the body 1 by the body 2. Okay, it is for the first object. Okay, so it is change in momentum on first object by change in time. And similarly, F21 can be written as F21 is force acting on body 2. So it should be change in momentum for object 2 by change in time. So with these two laws, we can relate these two laws to obtain the conservation of linear momentum. So for that, you have F12 value, F21 value related to momentum. So use this here in the third law. Apply 2 in 1. So instead of F21, you have to write it as dp2 by dt, and F12 it is dp1 by dt. So 1 is equal to minus of other one. So I am writing it as dp1 by dt equal to minus dp2 by dt. So you have minus here, bring this to one side. So if you bring minus to the left hand side, it becomes plus. Then it would be dp1 by dt plus dp2 by dt equal to 0. So you have this one is also change in momentum. This one also change in momentum with respect to time. So you can take the change, that is differentiation value out, which is d by dt of p1 plus p2, which is equal to 0. Which means you can see that change in the momentum is equal to 0. As I told you, conservation is to preserve from the change. It should have no change in the value. Whatever the linear momentum may be, the change should be 0. So change in momentum is 0, which proves that when will you have the value is 0, change value is 0, d by dt to any constant is 0. If you differentiate any constant with respect to any term, if you differentiate a constant, the value will be 0, which means this part is constant, isn't it? Because if you differentiate constant only, d by dt will be 0. So this means p1, p2 is constant. That is, total linear momentum is always constant. Constant means it will not change at all. So whatever the p value, how many ever values you add, the final value would be same. It is constant. This is what is the law of conservation. So what is the law? The law states that if there is no external force acting on the system, then the total linear momentum of the system is always a constant vector. As it is vector, the momentum is a vector quantity. So the resultant vector, if you don't apply any external force, these forces are only depending upon the objects in the system, and then this momentum, how many ever momentum it may be, the total linear momentum value of the system will be always a constant vector. That is, it is conserved with respect to time. Okay, so this is what is law of conservation of total linear momentum. Thank you.